So starting with 45, 45, 90, first we're going to talk about squares. So some facts about squares. All sides are equal, which means if one side is 1, we know that all the sides are 1. And then we know that we have 4 right angles. So each angle is a 90-degree angle. So if we want to find the length of the diagonal, we're going to split the triangle in half, and then we're just going to use Pythagorean Theorem on this right triangle here. So it's going to be 1 squared plus 1 squared equals c squared, c being the hypotenuse or the diagonal. So that's 1 plus 1. So c squared is 2, and then we're going to take the square root of both sides. So c is equal to the square root of 2. So the hypotenuse of this square would be square root of 2. So what we've done by drawing this diagonal is we've created a special right triangle, which is called a 45, 45, 90 triangle. And we're going to use this triangle to solve for missing sides in other triangles. So some facts about a 45, 45, 90 triangle. It's half of a square. The sides, we're going to call it has 2 legs, and the legs are both equal. And in a basic 45, 45, 90 triangle, the legs are both equal to 1. In addition, we have the hypotenuse, which is equal to the square root of 2. So the hypotenuse, we're going to highlight in yellow. And then we have our legs. Since they're the same color, I'm going to highlight them in blue. So what's nice about creating this triangle is that a 45, 45, 90 triangle is similar to all other 45, 45, 90 triangles by AA, meaning angle, angle. So any triangle, for instance, if you see this one over here, they both have a 90-degree angle, they both have a 45-degree angle, which means that these two triangles are similar. Okay, so we're going to use this triangle, which I'm calling the basic 45, 45, 90, to solve for missing sides in other triangles. All right, so in order to do that, these are the steps. So we're always going to use our basic 45, 45, 90 triangle, which is this triangle right here, where the legs are both 1 and the hypotenuse is the square root of 2. And we are going to match up our sides. So the hypotenuse is going to match up with the hypotenuse, and the legs are going to match up with the legs. And then we're going to cross multiply to solve. So we need to make sure we simplify as much as possible, which means we need to simplify our radicals, and we can't have radicals in the denominator. Fractions need to be simplified, and we're not going to have any decimals. All right, so let's look at this first example. So I'm going to use this basic 45, 45, 90 triangle here. First thing I'm going to do is I'm going to highlight my hypotenuse. Okay, and then I'm going to highlight my legs. So then once they're highlighted, we know that they can match up with these sides here. So the two sides that we need to solve for, we need to solve for DE, which is this side right here. Well, if we know the legs are congruent, that means that DE has to also be 3 square root of 5. So we already have one answer. And then we also need to solve for DF, which is this side right here. So in order to solve for DF, I'm going to go ahead and call that X. And I'm going to match up my sides. So that's a hypotenuse, so that needs to match up with the hypotenuse of my basic 45, 45, 90. So it's going to be X over square root of 2 equals, and then we're going to use the leg. So 3 square root of 5 over 1. So I matched up hypotenuse over hypotenuse equals leg over leg. Just like with similar triangles, we need to make sure if we start with this triangle in the first ratio, we need to make sure we start with this triangle in the second ratio. So once we're here, we're going to go ahead and cross multiply. So x times 1 is x, and then we're going to multiply 3 square root of 5 times the square root of 2. Remember from simplifying radicals that when they're both underneath the radical, we are allowed to multiply them. So we get x equals 3 square root of 10. And then we need to see if we can simplify this. But since my only factors of 10 are 1 and 10 and 2 and 5, and none of those are perfect squares, we know it can't be simplified. So that means we've solved for the sides. So that means df is 3 square root of 10. All right, now let's take a look at the second example. Again, first thing I'm going to do is I'm going to highlight my sides. So my hypotenuse I'm going to highlight in yellow, and I'm going to highlight my legs both in blue. So for this one, we're solving for JK, which is this side, and then KL, which is the bottom side, but we know they're congruent. So once I solve for JK, I know I have JL. So now that my sides are labeled or highlighted, I'm going to match up my sides. So I'm going to do leg over leg, so x over 1 equals, and then I'm going to do hypotenuse over hypotenuse. So 22 over the square root of 2. So for this one, we actually don't need to cross multiply since we already have x by itself. X divided by 1 is just x. So we have x equals 22 over the square root of 2. But remember, we can't have a radical in the denominator, so we have to use our big 1. And we multiply straight across. So 22 square root of 2 over 2. Next thing we need to check is if we can simplify these numbers on the outside, and we can. 22 divided by 2 is 11. So we have 11 square root of 2. So now I have my answer. That means I have JK. And since JK and JL are equal, we know that they both equal 11 square root of 2. Okay, now let's take a look at 30, 60, 90 triangles. So with 30, 60, 90 triangles, they're formed from an equilateral triangle. So a couple facts about an equilateral triangle. An equilateral triangle has all equal sides. And in addition, they have all equal angles, which means that every angle has to be 60 degrees since there's 180 degrees in a triangle. So we have 60 degrees, and 60 degrees. All right, so this is asking us to solve for the height of the triangle. So I'm going to draw that in. That's what we're solving for, which I'm going to call x. Well, since we just cut that in half, that means this side length would have to be 1. So now we're looking at this right triangle here. Using Pythagorean Theorem, it's 1 squared plus x squared equals 2 squared. So it's 1 plus x squared equals 4. Subtract 1. We have x squared equals 3, and then square root both sides. So x equals the square root of 3. So the height of my right triangle is square root of 3. Okay, so what we've done when we've cut this equilateral triangle in half is we formed what's called a 30, 60, 90 triangle. It's a 30, 60, 90 because the 60-degree angle up here got cut in half, so that's the 30-degree angle. The 60-degree angle is down here, and then we have the right angle. So in a 30, 60 degree, or a 30, 60, 90 triangle, it's half of an equilateral. Triangle. Okay, there's 3 sides that have formed, and we're going to call them the short side, which is equal to 1, and that's across from the 30-degree angle. Then we have the long side, which is equal to the square root of 3, and that's across from the 60-degree angle. And then we have the hypotenuse, which is equal to 2, and that's across from the 90-degree angle. So labeling my sides, this is 1, square root of 3, and 2. So just like before, I'm going to label or highlight my hypotenuse in yellow. I'm going to highlight my short side in blue and then my long side in green. So we're going to label these short, long, and hypotenuse. Just like with a 45, 45, 90, a 30, 60, 90 triangle is similar to all other 30, 60, 90 triangles, and again by AA. So then we can use this to solve for missing sides. So looking at our examples here, we have the step-by-step directions. It's pretty much the same as a 45, 45, 90. So we're going to draw our basic 30, 60, 90, which we need to make sure we have a short side, which is 1, a long side, square root of 3, and the hypotenuse, which is 2. And we're going to use this triangle to set up ratios to solve for missing sides of another triangle. Then we need to make sure that we simplify as much as possible. All right, so looking at our first example here, I'm first going to highlight my side. So my hypotenuse is yellow. My short side I'm highlighting in blue, and my long side I'm highlighting in green. Now we can color code. You're also welcome to label them SLH as well if you'd like. So now we're going to set up our ratios. So first side I'm going to solve for is NE, which is my short side. So my ratio is going to be x over, and I'm going to match it up with the short side of my basic triangle, x over 1. And then I'm going to use the information I have. Square root of 3, which is the hypotenuse, goes with 2. So I did short over short equals hypotenuse over hypotenuse. Now we cross multiply, but in this case, since x divided by 1 is x, I already have x by itself. So that means I actually have my answer. X is square root of 3 over 2. There's no need to cross multiply here. And actually, instead of writing x equals, I'm going to write the side name, which is NE. Okay, now I'm going to solve for my long side, which I'm going to call y. So y over square root of 3 equals square root of 3 over 2. So it's best to just use the same ratio that you used here. So I set up long over long equals hypotenuse over hypotenuse. Okay, we do need to cross multiply since y is not by itself. So this is 2y equals square root of 3 times square root of 3. So square root of 3 times square root of 3 is square root of 9. So I have 2y equals square root of 9. And remember that that is a perfect square. So 2y equals 3. And now to solve for y, we just divide by 2. So y equals 3 over 2. So that means that EW equals 3 halves. So really all we're doing here is just matching up sides. All right, now this last example here, I have my hypotenuse, I have my short side, and I have my long side. I'm going to solve for my short side first. So that's going to match up with 1. So x over 1 equals 12 over the square root of 3. So short over short equals long over long. Okay, this one we don't need to cross multiply since x is already by itself. So I have x equals 12 over the square root of 3. But I do need to rationalize my denominator. So I'm going to use my big 1. And then we need to check if we can simplify more, and we can. 12 divided by 3 is 4. So I have 4 times the square root of 3. So FU is 4 square root of 3. All right, now I'm going to go ahead and solve for my other missing side, which is the hypotenuse. I'll call y. I'm going to do that off to the side. So I'm going to do it in yellow here so you can see it. So y over 2. So I'm setting up hypotenuse over hypotenuse equals 12 over the square root of 3. And then we're going to cross multiply. So y square root of 3 equals 24, since 12 times 2 is 24. And now we're going to solve for y. Divide both sides by the square root of 3. And then we need to rationalize. So I'm going to take my big 1, which is going to be square root of 3 over square root of 3. So 24 root 3 over 3. And then if we can simplify, we should. 24 divided by 3 is 8. So I have 8 square root of 3. So my other missing side, which is ft, is 8 square root of 3. All right, so now let's take a look at a couple of the practice problems here. So first, looking at number 3, this is a 45, 45, 90 triangle. So I'm going to draw my basic 45, 45, 90 with 1, 1, square root of 2. My hypotenuse, I'm going to highlight in yellow, and then my legs, I'm going to highlight in blue. And now we're going to solve for the missing sides. So first, doesn't matter which one you start with, because remember in a 45, 45, 90 triangle, the legs are congruent. So v over 1 equals 2 root 3 over square root of 2. So I did leg over leg equals hypotenuse over hypotenuse. Okay, from here, I already have v by itself, but I do have a radical in the denominator, so I need to rationalize. So I'm going to take my big 1. So I have 2 square root, and remember we can multiply. Square root of 6 over square root of 2 times square root of 2 is just 2. And then lastly, these cancel out, so that gives me v equals square root of 6. And then since the legs are congruent, that means u also equals the square root of 6. Okay, now I'm going to do number 6. So this is a 30, 60, 90 triangle. So I'm going to draw my 30, 60, 90 triangle. We have the short side, which is 1, the long side, which is square root of 3, and the hypotenuse, which is 2. And I'm going to highlight my hypotenuse in yellow, my short side in blue, and my long side in green. And now we're going to match up our sides. So x is my long side, and that goes with the square root of 3, equals 4 square root of 3 over 2. So I did long over long equals hypotenuse over hypotenuse. Okay, this one we do need to cross multiply. So 2x equals, and then I have 4 square root of 3 times the square root of 3. So I have 2x equals 4 times the square root of 9. But remember, square root of 9 is a perfect square. It's just 3. And 4 times 3 is 12. So then I could divide both sides by 2. So x equals 6. Now to solve for y. Y is the short side, so that's going to match up with 1. So y over 1 equals 4 root 3 over 2. I already have y by itself, since it's y divided by 1, so 4 root 3 over 2, and then I can simplify this. So 4 divided by 2 is 2, so y equals 2 root 3. Okay, number 11 is a 45, 45, 90 triangle. So I'm going to make my 45, 45, 90 triangle. That's 1, 1, root 2. And I'm going to go ahead and highlight hypotenuse in yellow, my legs in blue. And now we're going to set up our ratios. Doesn't matter which one you start with. I'm going to solve for a first. So a over 1 equals square root of 2, equals 10 over the square root of 2. So make sure, if we're starting with this triangle, we need to make sure we start with the triangle in the second ratio as well. So I have a by itself because a divided by 1 is just a. So 10 over the square root of 2. We have to simplify, so square root of 2 over square root of 2. So the top becomes 10 root 2 over 2. And then we can simplify this to 5 square root of 2. And if we have A, that means we have B since the legs are congruent. All right, last one I'm going to do is number 10. Sorry, I kind of went out of order. I'm just going to use this special right triangle over here. So for number 10, I'm going to highlight my sides. So my short side is blue, my long side is green, and my hypotenuse is yellow. And we're just going to match up our sides. So I'll solve for x first, which is the hypotenuse. So x over 2 equals 9 over the square root of 3. Hypotenuse over hypotenuse equals long side over long side. And then we cross multiply. So we have x root 3 equals 18. Divide both sides by square root of 3. So I have 18 over the square root of 3. So now we need to rationalize. So square root of 3 times square root of 3. So we have 18 root 3 over 3, and then we can simplify this. 18 divided by 3 is 6. So we have 6 square root of 3. So there's x. And now to solve for y, y over 1 equals 9 over the square root of 3. So I did short over short equals long over long. We don't need to cross multiply because y is already by itself, but we do need to rationalize. So we have 9 root 3 over 3. And then this simplifies to 3 root 3.